So here's an example where we can apply the remainder theorem to help us solve some problems. So we've been given this cubic polynomial with an unknown k, and we've been told the division statement, if we divide by x plus 1, we're going to end up with a remainder of 3. Now we could kind of do the long division and solve it that way, but it gets a little bit complicated to do it. So we can do this much more easily using the remainder theorem. And what a remainder theorem states is that if I divide by x plus 1, then if I plug -1, the root, into the polynomial function, the answer should be my remainder. So my remainder of 3. So that's what I'm going to do. I'm just going to plug in -1 cubed plus 5 times -1 squared plus k. That's what I'm solving for. And I need to plug a -1 into there, plus 5. Okay, so I'm going to put my -1 into my polynomial. And the only thing left to solve for then is the k value. So then I get 3 is equal to -1. -1 squared is 1, so plus 5 minus k plus 5. So I need to solve for that k value. I'm just going to combine my like terms. So I get 3 is equal to 9 minus k. So then solving for k, I'm going to put k on this side. So k is equal to, and then 9 minus 3, k is equal to positive 6. Okay, so that's my value of k in that polynomial. That would give me this kind of remainder. In this next example here, we are given two unknowns to solve for, but we have two remainders to work with. So since I have two remainders, I can set up two equations. So I can set up an equation this way. So if I put in, I'll do one in green. So if I have f of -1, so if I plug -1 into my equation, I'm going to end up with positive 1 minus j plus 2 minus k plus 1. Okay, so I'm just going to put the k in that color there. And what I've done is I've plugged -1 into that equation. So then I need to generate, and sorry, this is equal to, when I do that, I get it equal to the remainder of -3. So that's equal to -3. I'm going to come up with a second equation based on the other statement there. So I could also plug in x equals 3, and I get a remainder of 169. So if I do f of positive 3, when I do that, I'm going to plug in 3 into this equation. So I'm going to get 3 to the power 4. That's going to be 81 plus j times 3 to the power 3, which is 27. So I end up with 27j. I'm going to put 3 into this, plus 2 times 3 squared. That's going to be 9 times 2, which is 18, plus, and I'm going to plug 3 into here. I get 3k plus 1, and that's all going to be equal to the remainder, which I was told was 169. So what I've done then is I've come up with two equations. Okay, so I have two equations, I have two unknowns, I can solve this as a system. So I'm going to call the green one equation 1 and simplify this. So I'm going to combine my like terms. So I end up with 1 plus 2 plus 1, that's 4 minus j minus k equals -3. Simplifying this, I'm going to add 3 to both sides and put j plus k on the other side. I can come up with a second equation based on f of 3. So combining like terms, I'm just going to go 27j plus 3k first. And then I'm going to move everything to the other side. So I end up with 18 plus 81 is 99, plus 1 is 100, so I'm going to subtract 100 from both sides, and I get 69. Since there's a common factor of 3, I'm going to divide this equation by 3, so take everything here and divide by 3. I'm going to get a simplified version of that equation. So now I have a system of equations. This is going to be easy to solve for because the k's already match up. So I have j plus k equals 7. I'm going to subtract those two equations. I end up with 8j is equal to 23 minus 7, which is 16. That gives me the j value of 2. So I've solved for j. I still need to solve for k, so I could just plug it back into either equation. So I'm just going to plug it back into equation 1. 7 is equal to j is 2 plus k. Okay, so I end up with k is equal to positive 5. So those are my two values that I was looking for, my j and k values.